Identify each equation as linear or nonlinear. In a linear equation, the variable has either an exponent of 0 or an exponent of 1, which shows up invisible in a lot of cases. Nonlinear could have an exponent other than 1 or negative exponents. So we're looking at these. Since this one has an x squared term, this one would be considered nonlinear. Maya predicts that the graph of x plus y equals 6 looks like the graph shown. Well, she has this point 0, 6, and 0 plus 6 does work, so it is a solution. She also has the point 1, 5, and 1 plus 5 equals 6, so that is also a solution. She has the point 4, 2, so if I replace the x values and the y values with the 4 for the x and a 2 for the y, that equals 6, so that is a solution. But do we think that the points are connected in a curve pattern? I disagree. Because I think that we could use halves to help us narrow this down even further. So for example, if I put 2.5 in the x position, I would need to add 3.5 in the y position to get 6. So 2.5, 3.5 would be this point here, which it doesn't go through. It should go through that point. So graph the equation. So we just mentioned that we had 2.5 as x. So we're replacing the x in the equation with the number 2.5. So 2.5 plus 3.5 would give us 6. So we're plotting that point. We could do 1.5, or 1.5 plus 4.5 would give us 6. We could do 0.5, and 5.5 plus 0.5 would give us 6. We could do -1. -1 plus 7 is 6. We could do +8. 8 plus -2 is 6, so 8, -2. We could do 6.5. 6.5 plus -0.5 is 6. We could do 5. 5 plus 1 is 6. We could do 10. 10 plus -4 is 6. We could do 9.25. And that would be negative 3.25 would give us 6. We could do 3.75. Well, we need to add a quarter to make it a whole number. That would put us at 4. So 4 plus 2 would give me 6. So 3.75 and 2.25. So you can see that the more information I add between the points, the more we start to see what type of line is created. And it's starting to appear to form a straight line or a diagonal line that is straight. And we can continue to add even more points. Like instead of 9.25, we could have done 9.2 or 9.1. There are infinitely many points that we can place on this line that would be solutions to this equation. But we can't graph all of the infinite points. So instead, what we do is we show a trend or a pattern to our data by using a line to represent what would occur with all of these points if we were to continue to plot more and more points. It would follow along this pattern, along this path. Let's start by thinking about, is this equation linear or nonlinear? Well, the x and the y both have an invisible exponent of 1. So this is a linear equation. If it's linear, what should the graph look like? Well, that word linear tells us that it should look like a straight line. So I'm going to choose two x values, and I'm going to solve them for y values to determine where to place my point. I always like to choose a 0 for x or a 0 for one of my variables because multiplying by 0 just gives me 0. So here this would be 3 times 0 plus y equals negative 8. 3 times 0 is 0, so that piece is gone, and I'm left with y equals negative 8. Then we can select another point. For example, 2 or negative 2. 3 times negative 2 plus y equals negative 8. Well, 3 times negative 2 is negative 6. If I add 6 to both sides, I get y equals negative 2. So I'm going to graph both of those points. And I'm going to connect them using a line. Now the question is, will you get the same line or a different line if you used different points? So if you were in class, maybe your classmate or your partner would have used different points, and the question is, do you get the same line? Well, if we change these values, let's try 2 different points and see if we end up with a different answer. So let's select negative 3 and negative 1. Well, 3 times negative 3 is negative 9. I'll add 9 to both sides, and that gives me y equals 1. So if I were to put these points on there, I would have negative 3, 1. Then I would have 3 times negative 1 is negative 3. I would add 3 to both sides. And I have y equals negative 5. So I'm going to go to the point negative 1, negative 5, which still show up on the exact same line. So regardless of the points or the values you chose for x, you're going to get the exact same line that I did, assuming you have your math correct. Now you can place as many points as you'd like along that line, but the minimum you need to create a line is 2 points. So at the least, at the bare minimum, if you know it's linear, you'll need 2 points to create a line. So here our equation is 1/3 x minus y equals 2, and this is linear. We need to use ordered pairs to graph the equation in the coordinate plane. Now, even though I am a math teacher, I am not a fan of fractions, especially when they're not nice fractions to work with. So I will choose an x value that is going to eliminate this fraction. If it's 1/3 of x, I'm going to pick a multiple of 3 so that I get a whole number value out of it. So I might choose a number like 3 or negative 6. So when I do the problem, 1/3 of 3 is 1. Then I can subtract 1. I'm going to move this down here. I'm going to subtract 1 from both sides. That leaves me with negative y equals 1. Then I have to divide by negative 1 to get a regular y, and that equals negative 1. Here I have 1/3 of negative 6 minus y equals 2. Well, 1/3 of 6 is 2, so 1/3 of negative 6 is negative 2. A different way that you could solve it is you could move this y over here. Then you have negative 2 equals 2 plus y. And then move this 2 back the other direction. Negative 2 and negative 2 make negative 4. So y here is negative 4. Then we graph the 2 points. We're going to go over 3 and down 1. For the next one, we're going to go left 6 and down 4. Then we will connect using a straight edge, which would be like a ruler or the edge of your book, and connect those points. Use the table to find 2 ordered pairs that satisfy the equation. Then use the ordered pairs to graph the equation in the coordinate plane. So our equation here is 4x minus 3y equals 12. Again, I told you I like to use 0 as one of them in these cases because multiplying by 0 is simple. Four times 0 is 0, so I'm just left with negative 3y equals 12. And then I can divide both sides by negative 3. Y equals negative 4. So 0, negative 4. You can also work the other way by putting the 0 in the y position and solving it for x. Negative 3 times 0 is 0, so I have 4x equals 12. Then divide both sides by 4, and you'll end up with x equals 3. So you'll go over 3 and then 0 and connect those points. Please make sure your workbook is filled in for lesson 13, and you can check back for lesson 14. Hopefully it will be posted soon. If you're checking back later, it'll probably already be there.